Hello everyone, for today's video tutorial we'll be going over the solution which I will work through for the tutorial session from last week where we started with flowcharting. I will be presenting a solution which I believe is the best way to answer the question. However, you may have had a different solution. There are multiple solutions to the problem. As long as it works and makes logical sense, you would have been awarded the marks that you deserved. So the question was to draw a flowchart that will be used to determine the lowest value from an input vector of several numbers. The size of this vector can vary, so that input vector is an input. The position of the lowest value in the vector must be returned. So we need to find where the lowest value is located. This must be performed using only basic operations, comparisons, and operators. So if we are to think of this as we have our input vector, let's for argument's sake say we have 6, 7, 5, 3, 4, 1. It's pretty clear for us to see that the smallest number is 1 and it's in position 6. But for the computer, it needs to compare each number one at a time. So if we imagine this as a bag that has a whole bunch of numbers in it, but we don't know what the numbers are beforehand, we can only take one number out at a time. So if we take a number out, our first number is number 6. That's the smallest number that we've seen so far. So we can say that that is our minimum. So minimum equals 6. And the position that the minimum was in is equal to 1, because it's the first one. If we then take another number out of the bag, the second number is a 7. Now we compare, is our 7 smaller than our minimum? So is the current number smaller than our minimum? If it is, we need to have a new minimum. If it's not, we just need to move to the next number. Every time we have a new minimum, we need to record its position. So we take out another number. We have a 5. That's now the third number that we've taken out of our bag. Now we check, is this number smaller than our minimum? In this case, yes it is. So our minimum is no longer 6, it is 5. And the position of that minimum is no longer 1, it is 3. Now we draw another number from the bag. That's 3, that's our fourth number. Is that number 3 now less than our minimum? Yes, again it is. So our minimum now is no longer 5. 3 in its position is 4. When we take our next number out of the bag, it's a 4. And that's now the fifth number that we've taken out of the bag. We check again, is our number less than our minimum? In this case, no, so we just take another number, and we take our last number out, which is the 1, and that now again is lower than our minimum, so we replace our minimum, and our position is 6. Now, we try and take another number from the bag, but there are no numbers left in the bag. So we check, is there another number? And in this case, there isn't. So if there isn't, we just output our result, which in this case is our position. So that's the logical process that we needed to follow. I can now break that down into logical steps. Okay, so the next step is to put what we've just done down into a flowchart. So the first thing that we need to do is we need to take the input of the vector after our start. So we use a rhombus to indicate a variable being input into the code or into the flowchart. And our input is called input vector. Okay. Now, remember we need to select each individual entry from our input vector and compare that to some minimum. We also need to keep track of how many times we're running the loop that we're going to need, and when we are at the end of our vector in order to exit. So we first initialize a few variables. Initialize just means to set their initial value. So we set our min equal to the first position in our input vector, we do this by indexing the first position in that vector, and we then set a counter variable which just allows us to keep track of which position in the vector we're currently looking at. We can set that equal to 2 because we don't need to compare the first number to itself. We then have a discriminator which says, we're now comparing each number to our minimum value. So we say is input vector index counter. So all we're saying here is the current position of our input vector less than our minimum? If it is, we need to have a new minimum. If it's not, we need to just take our next value. So we'll have an arrow for no, or a flow path for no, and we'll have a flow path for yes. If our current value is lower, then we need to set a new minimum. So that would be like in the case where we pull out 5 after pulling out 7. Our current value is lower than our previous minimum of 6, and we then need to make 5 our new minimum. So our new minimum is equal to input vector counter. Okay, so we've taken the current position of our input vector and set it as our new minimum, provided that it is smaller than our old minimum. We then also need to keep track of that position, and I'm just going to call that variable index. Remember guys, it doesn't matter what you call these variables, it just needs to make sense to you. We're going to set that equal to counter, because counter is the current position of the new minimum that we have found. And then we go into another discriminator. This is now to check. Once we've made our comparison, we need to move to the next number. Before we can move to the next number, we need to check, is there another number to compare? So we say, is counter greater than or equal to, I'm going to use a function here, length of input vector. The length function will return the number of elements within that vector. If you had said something like, is there another number, etc., for the purposes of this tutorial, it would have been fine. So if there is another number, we increase our counter variable. So we can say increase counter by 1. Remember guys, counter is not a special function or a special object. All it is a variable that we've given the name counter, and we're increasing it every time we run the loop to keep track of which position of the input vector that we're referring to. Okay, so that loop will now run through the entire vector. That should be no. If we have reached the end of the vector, so if counter is greater than the length of our input vector, we then exit and we output our index variable. And then we can end our loop. Okay, so now if we look at question 1b, it says that we need to modify the flowchart to remove the lowest value from the input vector and then repeat the process any number of times. So our current flowchart tells us what the position of the lowest value is. We then need to add a command to remove it, and we need to add a loop in order to repeat it any number of times. Any number of times means that we need a variable input from the user that tells us how many times it needs to be run. So we need to create that input variable. The input variable that I'm going to use in this case will be num r for num removals. Okay, so that gets input by the user. We then need to add a discriminator at the end of our current flowchart in order to start our loop. Where we check now how many times have we run it. So in order to do that, we need a second counter to count the second loop. So we say counter 2 is equal to, and we'll start that at 1. We then need to check, is our second counter greater than or less than our number of removals. So is counter 2 greater than num r. If our second counter is greater than that number, it means we've run our loop the correct number of times, so we can end. If it's not greater than that number, it means we need to run our loop again. So inside that loop, we need to do our removal. And in order to do that, we just say input vector, and in this case index is equal to, and we set it equal to empty square brackets. That will remove that entry from the vector. We use index because index is the position we've identified as being the position of the lowest number. Okay, so in order for our loop to run, we need to increase the value of our counter variable. So we increase counter 2 in this case by 1, and we loop back in to the start of our previous flowchart code after the initialization. So every time you run through this code, we check how many times have we done a removal. If it's less than the number of times we need to, we do a removal. We increase that counter by 1, and we go into this original code to find the new minimum. And once we found the new minimum, we then check again, do we need to make a removal? If we need to make a removal, we go again, we make a removal, we find the new minimum. If not, then we just end our code. Okay, in this case, it doesn't specifically ask you to do an output. If you are going to use this as a function for your next code, you will need to output something. So we can just say that output vector is equal to input vector now, because that input vector has had entries removed. And then we can say output OV, and we can then end our flowchart. Okay, thank you guys. So this flowchart that we've just used will have an input. It'll have two inputs, input vector and numR, and it'll have a single output vector, where the inputs are your original vector as well as the number of times you need to remove something, and your outputs are, in this case, your output vector. If we were to use it as a function, so we could call this whole thing min index position. Okay, the input to that function would be a variable that tells us how many times we make the removal and some input vector. The names of those don't really matter as long as they have the right format. So we could have IV over here and a variable called num over there, where the first variable is the input vector and the second variable is the number of times you need to remove something, and we could then set it equal to some output variable. And that's how you would reduce this entire flowchart to a single function or process block to use in question 2.